Ladies and gentlemen, the event will be beginning shortly. For those who still staying outside the ballroom, we'd like to invite you to come into the auditorium. Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. To the Honorable Rector of Universitas Trisakti, Professor Dr. Insinyur Kadarsa Suryadi, DEA. To the Honorable Rector of Universitas Pembangunan Jaya, Professor Elizabeth Rukmini, PhD. To the Honorable the Vice Rector 4 of Universitas Trisakti, Ibu Profesor Dr. Gigi Tri Eri Astuti, MKes, FISDPH, FISPD. The Honorable Dean of Faculty Industrial Technology Universitas Trisakti, Professor Dr. Insinyur Rianti Dewi Slamet Aryo Bimo, ST Master of Engineering ITU. The Honorable Deputy Dean and Academic, Faculty of Mechanical Engineering and Technology, University Malaysia Perlis, Associate Professor, Insinyur of Technologies, Dr. Muhammad Rizwan bin Muhammad Jamir. The Honorable Head of Mechanical Department, Faculty of Mechanical Engineering and Technology, University Malaysia Perlis, Associate Professor, Insinyur Dr. Muhammad Tashrif Abdul Rahman. The Honorable Keynote Speaker, Associate Professor, Flight Lieutenant Dr. Kontorn Champin Prasad from Raja Manggala University of Technology Isan, RMUTI, Thailand. The Honorable Keynote Speaker, Professor Doctor of Engineering Manabu Enoki from Tokyo University of Technology, Japan. The Honorable, the representative from Raja Manggala University of Technology, Isan, RMUTI, Thailand, Assistant Professor Dr. Witaya Daudon and Dr. Harutai Maskong. The Honorable Guest, Professor Yuji Sato from the University of Osaka, Japan. The Honorable Guest, Professor Arif Budiman from Oregon Institute of Technology, USA. The Honorable Mr. Wijanarko MSc as Director of Technical and Government Affairs, Toyota Motor Manufacturing Indonesia. The Honorable Mr. Irwin Tristanto as General Manager of Engineering Division, Toyota Motor Manufacturing Indonesia. The Honorable, the Chairwoman of Icadme 2025, Associate Professor, Insinyur of Technologies, Dr. Fauzia Mat from University Malaysia Perlis. The Honorable, the Chairman of Ista-Am 2025, Dr. Zaki Saptari Saldi from Universitas Pembangunan Jaya. The Honorable Deans, Directors, Vice Deans, Head of Bureau, Head of Unit, Head of Department from Universitas Trisakti and fellow universities, and to all participants that could not be mentioned one by one. My name is Prayang Sani Yulia. Welcome to the 9th International Conference on Applications and Design in Mechanical Engineering, Icadme 2025, and the 2nd International Conference on Science, Technology, and Applications of Additive Manufacturing, Ista-Am 2025. Thank you very much, ladies and gentlemen. So this event is held on Heri Hartanto Building, FNG Auditorium, 8th floor, Faculty of Industrial Technology, Universitas Trisakti, Jakarta, on 1 until 2 December 2025. So ladies and gentlemen, before we proceed, for safety reason, please allow us to give the video of safety induction.
Selamat datang di Gedung Heri Hartanto, Fakultas Teknologi Industri, Universitas Trisakti, Jakarta.
Gedung ini terdiri dari 8 lantai dengan 2 bagian gedung yang disebut Gedung F dan G. Terletak di sebelah selatan Jalan Kiai Tapa atau di sebelah timur Jalan Letjen S. Parman, Tomang, Jakarta Barat.
Mengikuti Permen RI nomor 36 tahun 2005 pasal 59 tentang keharusan sebuah gedung menyediakan sarana evakuasi dan sistem peringatan bahaya manakala terjadi bencana. Maka gedung ini memiliki sarana dan sistem peringatan bahaya sebagai berikut. Terdapat 3 jalur evakuasi di gedung ini, yaitu 2 jalur evakuasi melalui pintu darurat di sebelah barat gedung melewati tangga yang kemudian keluar di pintu barat menuju assembly point atau titik kumpul di taman sebelah barat gedung. Jalur evakuasi lainnya adalah melalui tangga darurat tanpa pintu di sebelah timur menuju lobi di lantai dasar, lalu keluar menuju assembly point atau titik kumpul di halaman sebelah timur gedung.
Gedung ini dilengkapi smoke detector dan fire sprinkler yang terhubung dengan fire alarm yang terdapat di tiap lantai. Dan semuanya terhubung ke panel induk alarm yang terletak di lantai dasar gedung. Di sebelah timur di setiap lantai gedung terdapat alat pemadam api ringan atau APAR. Adapun cara penggunaan APAR adalah sebagai berikut. Tarik kunci pengaman. Pegang bagian ujung selang dan arahkan ke sumber api. Tekan tuas. Kibaskan ujung selang hingga api padam.
Bencana datang tidak pernah kita duga, khususnya kebakaran. Kita dapat meminimalkannya dengan cara sebagai berikut. Tidak membuang puntung rokok secara sembarangan, tidak menggunakan stop kontak melebihi batas beban 1500 watt, selalu mematikan peralatan elektronik setelah tidak dipergunakan dan mencabut kabelnya dari stop kontak. Apabila timbul asap yang cukup banyak atau panas yang tinggi, smoke detector dan fire sprinkler akan bekerja otomatis. Fire alarm akan berbunyi. Pada panel induk alarm akan dapat dilihat lokasi dari mana asap atau panas yang tinggi itu berasal.
Di awal terjadinya kebakaran, menjadi tugas building captain untuk melakukan penanggulangan awal terhadap kejadian kebakaran dan juga meminimalkan akibat-akibat dari kebakaran tersebut. Apabila api tidak bisa dipadamkan menggunakan APAR, maka building captain dibantu petugas lainnya memadamkan api dengan menggunakan hydrant kabinet. Bila kebakaran tidak bisa diatasi juga, maka building captain akan menelpon pemadam kebakaran di nomor 112 dan meminta teknisi untuk mematikan listrik di lantai yang terjadi kebakaran.
Jika alarm tidak berbunyi saat terjadi kebakaran, individu yang melihat pertama kalinya bisa menekan manual call point atau tombol manual fire atau segera melapor kepada building captain di extension 8425 atau petugas keamanan dengan nomor 566-3232 extension 8169 yang kemudian akan menyalakan manual call point secara manual untuk menghidupkan alarm kebakaran.
Di saat hari libur atau di luar jam kerja, maka menjadi tugas satuan pengamanan untuk bertanggung jawab dalam melakukan langkah-langkah penanggulangan kebakaran yang terjadi. Berikut ini langkah-langkah evakuasi saat terjadi kebakaran. Demikianlah safety briefing untuk Gedung Heri Hartanto, Fakultas Teknologi Industri, Universitas Trisakti, Jakarta.
Patut diketahui bahwa gedung ini adalah area bebas rokok. Jadi, kepada siapapun yang berada dalam gedung untuk tidak merokok. Terima kasih.
Thank you very much, ladies and gentlemen, for your attention to the video of safety induction. Ladies and gentlemen, let us sing the national anthem of Indonesia, Indonesia Raya, the national anthem of Malaysia, Negaraku, and Mars Universitas Trisakti. Please all rise. Thank you, and please be seated. Distinguished guests and all participants, so to mark the beginning of today's event, we proudly present the opening performance, the Indonesian traditional dance from students of Universitas Trisakti. This is Cupang Menor Dance. Once again, give applause for students of Universitas Trisakti with traditional dance Cupang Menor dance. And this dance is portrayed the youth and beauty of the girls and originally from Betawi or Jakarta. So ladies and gentlemen, this is the upcoming agenda. Now we will hear the remarks from the chairman of Ista-Am 2025. Therefore, please welcome to Dr. Zaki Saptari Saldi. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. A very good morning, distinguished guests, presenters, ladies and gentlemen. On behalf of the organizing committee, I am honored to welcome you to the International Conference of Science, Technology and Applications of Additive Manufacturing, Ista-Am 2025. This conference brings us together to exchange insights and explore new collaborations in additive manufacturing research. Building on the success of the previous Ista-Am conference in Bali back in 2024, this time we are very excited to organize this event jointly with the 9th International Conference on Applications and Design in Mechanical Engineering, Icadme 2025, creating opportunities for cross-disciplinary exchange. This year, Ista-Am has received a total of 28 submissions comprising keynote talks, session keynotes, invited talks, and contributed papers distributed across 6 technical sessions. There are 2 sessions on scientific advances in additive manufacturing, also design for additive manufacturing, engineering applications of additive manufacturing, AI, IoT, and Industry 4.0 innovations in manufacturing, also emerging technologies and energy sustainability in manufacturing. The contributions come from Indonesia, Malaysia, Singapore, Taiwan, Japan, Australia, and the United States, reflecting the growing interest and collaboration within the global AM community. Thank you very much to all contributors, keynote speakers, invited speakers, paper presenters who have submitted their abstracts and will present their work at this conference. We really highly appreciate Professor Manabu Enoki and Professor Yuji Sato, 2 of our keynote speakers who flew all the way from Japan to share their talks at Ista-Am 2025. We also appreciate Prof. Jaya Suteja from Universitas Surabaya, who also flew all the way from Surabaya to join us at this conference. I would also like to express our sincere appreciation to Universitas Trisakti and the Faculty of Industrial Technology for hosting and providing substantial support for this conference. Thank you, Pak Rektor, Professor Kadarsha Suryadi, and the Board of Management of Trisakti University. Also, Ibu Din, Professor Rianti Dewi Sulamat Aryo Bimo, and the Board of Leadership at FTI Usakti for their support. Our deepest gratitude definitely goes to Icadme 2025 Committee, Faculty of Mechanical Engineering and Technology, University Malaysia Perlis, UNIKL, and Raja Mangala University of Technology, ISAN, for warmly embracing the joint organization of these 2 conferences. Thank you, Prof. Sariman bin Abu Bakar and Dr. Fauzia Bitimat, and all the Icadme committee members. We thank Dr. Fauzan Aziman, Director General of Research and Development, the Ministry of Higher Education, Research and Technology, for his support and grace of this conference. Dr. Fauzan will join us through virtual platform tomorrow morning to open the 2nd day program. We highly appreciate Professor Satrio Sumantri Brojonegoro, Trihita Karana Center for Future Knowledge, PT Toyota Motor Manufacturing Indonesia, Timin, and PT Geodipa Energy for their strong support. Special thanks to Pak Irwin, Pak Wijanarko, Pak Jaka, and also Pak Fajar, who are present with us today from Timin. Thank you very much. I'm truly grateful for the advice and support from the Advisory Board of Ista-Am, Professor Elizabeth Rukmini, Rector of Universitas Pembangunan Jaya. Thank you, Bu Bet. Professor Rianti Dewi Slamet Arya Bimo, Dean of FTI Trisakti, and Professor Linawati, Dean of Faculty Engineering Universitas Udayana. Also, the Scientific Committee of Ista-Am, Professor Tim Pasang from Western Michigan University, Professor Jia Chang Wang, and Professor Cho Pei Jiang from National Taipei University of Technology, Professor Fergianto Gunawan from Binus Aso School of Engineering, Professor Inyoman Budiarsa from Universitas Udayana, and Professor Arif Budiman from Oregon Institute of Technology, the chairman of Ista-Am 2024, and also happens to be the one who pushed me into this chairmanship thing. Last but not least, I'm really thankful to the organizing committee, Dr. Nora Azmi, Dr. Endang Juana, and the rest of the FTI Trisakti team. Thank you very much. And also Dr. Triwanto Simanjuntak and Dr. Reza Octavianti from IULI for such a great collaboration, dedication, and hard work. Whether you are joining us in Jakarta or online, I hope you all find Ista-Am 2025 intellectually stimulating and rewarding. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to Dr. Zaki Saptari Saldi as the chairman of Ista-Am 2025. Ladies and gentlemen, for the upcoming agenda, we will hear the remarks from the Deputy Dean and Academic Faculty of Mechanical Engineering and Technology, University Malaysia Perlis, as host of Icadme 2025. Please welcome to Associate Professor in Senior Technologies, Dr. Muhammad Rizwan bin Muhammad Jamir. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and warm greetings to everyone. It is truly an honor for me to represent the Faculty of Mechanical Engineering and Technology, University Malaysia Perlis, UNIMAP, in delivering this speech today. I'm delighted to extend a warm welcome to all participants of the NIE International Conference on Application and Design in Mechanical Engineering Icadme 2025, which is this year is proudly held in conjunction with Ista-Am, the International Conference on Science, Technology and Application of Additive Manufacturing. Let me begin by acknowledging our distinguished guests, Professor Dr. I.R. Kadrasah Suryadi, Rector of Universitas Trisakti Indonesia, Professor Dr. I.R. Rianti Dewi Slamet Arya Bimo, Dean Faculty of Industrial Technology, Universitas Trisakti Indonesia, Dr. Zaki Saptari Saldi, Chair of Ista-Am 2025, Universitas Pembangunan Jaya, representative from Raja Manggala University of Technology Isan, RMUTI, Assistant Professor Dr. Witaya Dakdun, and Dr. Harutai Maskong, members of organizing committees from UNIMAP, Universitas Trisakti, and RMUTI, our keynote speakers, presenters, and all participants. Ladies and gentlemen, this year marked another important milestone for Icadme. For the first time since its inception, Icadme is being hosted outside of Malaysia, and we are truly honored to have Universitas Trisakti as our host here in Jakarta. This moment signifies not only the growth of the conference, but also the strengthening of the regional partnership and academic collaboration across ASEAN. The decision to bring Icadme to Indonesia reflects our shared commitment to expanding knowledge network, encouraging the mobility of the ideas, and fostering cross-border collaboration in engineering, research, and innovation. While we initially aimed for around 100 submissions, we are delighted to share that we have received more than 110 papers, surpassing all expectations. This submission came from the a diverse group of countries, including Indonesia, Thailand, Italy, the United States, India, Japan, Bolivia, and of course Malaysia, highlighting the truly international reach and impact of this conference. UNIMAP is deeply grateful to our partners, Universitas Trisakti, RMUTI, and UniKL for joining hands with us. This collaboration reflects the essence of ASEAN cooperation, working together to nurture talent, advance research excellence, and contribute to technological progress. As you participate in today's presentation and discussion, I encourage you to engage openly, exchange ideas, and explore opportunity for future collaboration, although we gather here for just one day, and the knowledge shared and the connection built will have lasting impact. Before I conclude, I would like to express my heartfelt appreciation to Universitas Trisakti for hosting this milestone edition of Icadme, and to all committee members and our sponsors for their dedications and support in making this event a success. With that, I wish everyone a productive, enriching, and inspiring conference. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to Dr. Muhammad Rizwan bin Muhammad Jamir from University Malaysia, Perlis. So ladies and gentlemen, for the following agenda, this is the remarks and also the opening of Icadme 2025 and Ista-Am 2025 by the Rector of Universitas Trisakti, Professor Dr. Insinyur Kadarsah Suryadi, DEA. And in this opportunity, Bapak Professor Kadarsah will deliver the remarks online. Therefore, please welcome to Professor Kadarsah Suryadi. Time is yours.
Thank you, Bu Prayan. Can you hear my voice, please?
Sure, loud and clear, Prof.
Yes, Prof.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Honorable, distinguished ladies and gentlemen, good morning and a very welcome to all of you. It is great honor for Universitas Trisakti to host these two prestigious international conference collaborations between the International Conference on Application and Design in Mechanical Engineering, Icadme 2025, and the International Conference on Science, Technology, and Applications of Additive Manufacturing, Ista-Am 2025. We are deeply grateful for your presence, whether you have traveled from within Indonesia or from across the globe. And allow me also to extend a special welcome to our distinguished guests who are joining us today. Professor Satrio Sumantri Brojonegoro, my awesome senior, my mentor, who is joining us from Tokyo by online today. Professor Elizabeth Rukmini, PhD, Rector of Universitas Pembangunan Jaya, Associate Professor Insinyur Dr. Muhammad Rizwan bin Muhammad Jamir, Vice Dean of FMET, Faculty of Mechanical Engineering Technology, University Malaysia, Perlis, UNIMAP, and host of Icadme. Dr. Zaki Saptari Saldi, Chairman of Ista-Am 2025, Associate Professor, Insinyur Dr. Fauzia Ahmad, Chair of Icadme 2025. Professor Arif Budiman from Oregon Institute of Technology, Associate Professor Insinyur Dr. Muhammad Tasrif Abdurrahman, Head of Mechanical Engineering, UNIMEP. And also I would like to say hello to our keynote speaker, Associate Professor Dr. Kontorn Samni Prasad from Suvarnabhumi University of Technology, Thailand. Professor Dr. Engineer Manabu Enoki from Tokyo University of Technology, Japan. Professor Dr. Rianti Dewi Sulamet Aryabimo, the Dean of FTI Universitas Trisakti. Associate Professor Dr. Engineer Yoshi Sato from University of Osaka. Bapak Taryono Purba, Toyota Motor Manufacturing Indonesia, and Professor T. Jaya Suteja, PhD from Universitas Surabaya. And I would like to say also hello to Bapak Wijanarko, Director of Toyota Motor Manufacturing Indonesia, Bapak Irwin Tristanto, General Manager of Toyota Motor Manufacturing Indonesia, all invited speakers, Vice Rectors, Dr. Burhanuddin Nur, Professor Komsia, Insinyur Yoska Octaviano, FTMT, and Professor Tri Astuti, all the deans from universities and from Universitas Trisakti that have joined and participated, all guests and participants. Thank you for honoring this event with your presence and continued support. I would also like to acknowledge the inspiring remarks given earlier by Dr. Zaki Saptari Sadi and Dr. Muhammad Rizwan bin Muhammad Jamir. Your contributions continue to strengthen our international academic partnership and enrich our collaborative endeavors. This year, Icadme theme, Resilient Engineering for Climate Change, Innovation in Mechanical Systems, is both timely and essential. Climate change has become an urgent global challenge, and engineering innovation plays a vital role in developing resilient systems, sustainable materials, and transformative technologies. By bringing together Icadme and Ista-Am, we unite two dynamic fields, mechanical engineering, which supports the foundation of modern industrial development, and additive manufacturing, which is reshaping how products are designed, optimized, and produced sustainably. Our gratitude extends to all keynote speakers and invited speakers who will share their insights and research throughout this event. Your participation enriched the academic quality and international relevance of this collaboration. This international conference collaboration offers a valuable platform for interdisciplinary dialogue, groundbreaking research discussions, and global cooperation. Over the next few days, we hope you will engage in stimulating exchanges, forge new partnerships, and contribute to shaping the future of engineering and manufacturing. To all presenters, researchers, industrial experts, and participants, thank you for dedicating your expertise and energy to this conference. Your engagement is crucial in driving forward innovative solutions that benefit society at large. I also wish to express my sincere appreciation to the entire organizing committee for their hard work and professionalism in bringing this collaborative event to life. On behalf of Universitas Trisakti, I wish you a productive, inspiring, and successful conference. May Icadme 25 and Ista-Am 25 lead to meaningful discoveries and lasting international cooperation. Thank you once again and welcome to Universitas Trisakti. I wish you all a fruitful conference. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Bapak Profesor Kadarsa Suryadi as Rector of Universitas Trisakti. So to Bapak Profesor Kadarsa, would you please to stay a while for the opening ceremony, because the opening ceremony will be conducted hybridly. And so now shall we invite for coming to the stage. First, please welcome to the Vice Rector for Universitas Trisakti, Ibu Profesor Tri Eri Astuti will on behalf Bapak Rektor for sounding the instrument. And then please welcome to Rector of Universitas Pembangunan Jaya, Ibu Profesor Elizabeth Rukmini. And then please welcome to Dean of FTI Universitas Trisakti, Ibu Profesor Rianti Dewi Slamet Aryo Bimo for coming to the stage. And then please welcome to Deputy Dean and Academic Faculty of Mechanical Engineering and Technology University Malaysia Perlis, Dr. Muhammad Rizwan bin Muhammad Jamir. And then please welcome to Chairwoman of Icadme 2025, Dr. Fauzi Ahmad. And then the Chairman of Ista-Am 2025, Dr. Zaki Saptari Saldi. And then we also would like to invite the keynote speaker, Professor Manabu Enoki, please welcome. And then the representative from RMUTI Thailand, Dr. Witaya Daudon and Dr. Harutai Maskong, please welcome to the stage for the opening ceremony. So ladies and gentlemen, for today opening ceremony will be conduct hybrid. In here for the offline, we already have the board, and then Ibu Prof. Eri will sound the instrument after Bapak Rektor Universitas Trisakti give the opening address. So for the opening ceremony, we will give it back. Please welcome to Bapak Profesor Kadarsa Suryadi for the opening address.
Thank you, Bu Prayang. Honorable, distinguished ladies and gentlemen, I declare that the International Conference on Application and Design in Mechanical Engineering Icadme 2025 and the International Conference on Science, Technology and Applications of Additive Manufacturing Ista-Am 2025 officially open.
Thank you very much, ladies and gentlemen. And continue with photo session, please, ladies and gentlemen. And to the team from Universitas Trisakti, please make a count. And also will be photographed with Bapak Rektor also hybridly. So please to Tim Humas. So please to VIP guests to move aside to the center. Okay, thank you very much, Bapak Rektor, ladies and gentlemen. So once again, we will have photograph with all participants down here. So please welcome, ladies and gentlemen. And to all participants, would you please to all rise? We will take a picture together before we start this conference. Thank you very much. We really appreciate. Yeah, for VIP guests, would you please to make the front line and will be arranged by our team, our officials for the photograph. All right, so everybody ready? And our team will make sure all participants are in one frame. Okay, so please to count from 3, 2, 1. In 3, 2, 1. Okay, so one more with Trisakti pose. It's like here, ladies and gentlemen. Yeah, yeah. The three fingers. Okay, Trisakti. Yeah, representing for Trisakti. Okay, thank you, Pak Iwan. Okay, again in 3, 2, 1. Okay, thank you very much, ladies and gentlemen. All right, so that's the opening ceremony of Icadme and Ista-Am. And for now, we will invite you to enjoy the coffee break because we are going to have a break time in 15 minutes. And then we will continue to the keynote speaker session. So for everyone who wants to enjoy the coffee, beverage, and snacks, you are allowed to have it in this auditorium. And also, we would like to say thank you to all sponsors for your support. Thank you very much to our sponsors, the Boeing Company, Talent Corp Corporation Malaysia Berhad, Asia Berseri Vision, Math Proof Read, Senfotech, and PT Geodipa Energi Persero. Those are our sponsors. So distinguished guests, ladies and gentlemen, we'll be right back shortly after this break time, and then we are straightly continue to the keynote speaker session. Thank you very much. So, ladies and gentlemen, we would like to inform you the next session will be started in a few minutes. So, you may enjoy and bring your coffee and snacks at your table while enjoying also for the keynote speaker session. Thank you. Okay, so good morning. Hello again, ladies and gentlemen. So I'm Prayang Sani. It is so pleased to have you all in here. And now we will continue for the next session. This is the keynote speech session. And for today, the keynote speaker session will be conducted by our moderator. And please, we'd like to invite first Ibu Insinyur Anissa Bikuning ST, Master of Engineering, PhD. Please give applause to our moderator, Ibu Anissa. Please welcome, Ibu. Okay, so our moderator already in here, and firstly, let us introduce the briefly introduction for our moderator, Ibu Insinyur Anissa Bikuning, ST, Master of Engineering, PhD. Currently, Ibu Dr. Anissa is the head of Department, Master Program of Mechanical Engineering, Faculty of Industrial Technology, Universitas Trisakti. Ibu Dr. Anissa complete her bachelor degree in Mechanical Engineering from Universitas Trisakti, Indonesia. Then she complete her master degree in Mechanical Engineering from Ritsumeikan University, Japan, and complete her doctoral degree from Doshisha University. Ibu Dr. Anissa has many notable experiences for becoming the leader on research and community service and published articles in many reputable journals, both national and international. So, ladies and gentlemen, without further ado, I'll pass to Ibu Dr. Anissa. Please welcome, time is yours.
Okay, thank you, Mbak Prayang. Thank you. Ladies and gentlemen, distinguished speakers and honorable participants online and offline, good morning and welcome to the keynote speaker session with me of our international conference. Today, we are pleased to have 4 distinguished keynote speakers who will share valuable insight on sustainable industry, clean energy, advanced manufacturing, and casting technology. Please be informed that the question and answer will be conducted after all 4 keynote speakers have completed their presentations. Okay, our first keynote presentation will be delivered by Professor Dr. Insinyur Kardarsah Suryadi, DAA IPU, Rektor Universitas Trisakti Indonesia. The presentation title is Lifelong Learning for Sustainable Future, Boosting Green Industry, Resilience, and Human Life Quality. Professor Dr. Insinyur Kardarsah Suryadi is an academic leader with over 3 decades of experience in higher education, industrial engineering, and national level university governance. A graduate from Institut Teknologi Bandung, with advanced degrees from France in industrial engineering and decision support system. He has held several prominent positions, including Director of Education at ITB, Vice Rector, and ultimately Rector of ITB from 2015 to 2020. He currently serves as Rector of Universitas Trisakti. His contributions have earned him numerous national recognitions, including Man of the Year 2023, Academic Leader Award, and multiple Satya Lancana. His research spans sustainability, management of technology, and strategic decision making. Okay, We would like to inform all participants that our first keynote speaker will join us online. Okay, Professor Kadasa.
Yes.
Okay,
Bu Anis.
Professor, you may now begin your presentations. You will have 70 minutes. Thank you.
Thank you, Bu Anis. Assalamualaikum warahmatullahi wabarakatuh. Honorable, distinguished ladies and gentlemen, it's good to see you again. Pak Satrio, thank you for attending this seminar, this conference. I'm very glad to see you again. And salam sehat selalu, Pak Satrio, my mentor, my senior Ausam. Ladies and gentlemen, allow me to present a humble topic in this session. It's about the role of lifelong learning, green industry and human life quality and achieving sustainable development. And my specific topic is lifelong learning for a sustainable future, boosting green industry resilience and human life quality. And allow me to share my file. Okay. Okay, my topic is very humble about lifelong learning for a sustainable future, boosting green industry resilience and human life quality. As an introduction, I would like to tell you that human life quality, green industry, and lifelong learning are interconnected concepts that are trending topics both individually and as cause and effect theories. That's why I would like to tell 3 points in this occasion. The first point is human life quality, the second is green industry, and the third point is lifelong learning. We come now to the first point, human life quality. The interest increases when the topic of sustainable development is raised. And the World Health Organization defines quality of life as an individual's perception of their position in life in the context of the culture and value systems in which they live and in relation to their goals, experience, standards, and concerns, which covers wealth, employment, environment, physical and mental health, education, recreation, and leisure time, social belonging, religious beliefs, safety, security, and freedom. Generally, there are several indexes used to measure human life quality, but the most common ones are Human Development Index and the Life Quality Index, or LQI. Human Development Index was invented by United Nations Development Program, UNDP, to depict the average achievement of a nation in a long and healthy life, knowledge, and decent standard living. So, it is the dimensions of Human Development Index: long and healthy life, knowledge, and decent standard of living. These dimensions are elaborated in the very operational dimension index, such as life expectancy index, educational index, and gross national income index. According to the report released by UNDP in 2023, the highest SDI was Iceland. The score is about 0.972. And Indonesia SDI was 0.728, which increased by 0.002 from 2022. And we come now to the second point, is about green industry. Referring to the parameters mentioned by HDI, the green industry will play an important role since it will contribute positively to the most HDI parameters. The green industry was introduced by United Nations Industrial Development Organization, UNIDO, in 2009. UNIDO described GI as methods to achieve sustainable economic growth and promote sustainable economies. It includes policymaking, improves industrial production processes, and resource efficient productivity. And in simple, the green industry is defined as industrial development that not only focuses on economic growth, but also enhances environmental sustainability and human well-being. There are some key aspects of green industry, such as renewable energy, energy efficiency, green construction, clean manufacturing, sustainable agriculture, ecotourism, and waste management recycling. On the other hand, Human Development Index consists of some other aspects, such as wealth, environment, employment, mental health, physical health, education, and safety. Justifying a product of green industry is not as simple as introducing an electrical car. When an electric car is introduced, it is directly recognized as green technology. This is true on one hand, but further investigation should be broader to analyze not only the car, but also the energy sources used during production, delivery and resource material handling, waste disposal, energy sources during use, and finally, battery disposal. All processes should be covered by the green industry system. So, green industry is not a static and sudden change, but a dynamic, progressive, and sustainable movement. Due to tremendous characteristic of green industry movement, resilience is needed to ensure that the change occurs. Environmental awareness and sustainable concerns increase with the changing industrial era. But energy consumption also increases. But energy consumption also increases. Process reconfiguration cost and maintenance simplicity decrease as product customization and individualization increase. Product characteristics tend to change from mass production to customization, leading to increased value creation. We see in this picture that when Industry 1.0, Industry 2.0, the environmental awareness and sustainable concerns is low. But when we come to Industry 4.0, environmental awareness and sustainable concerns is very high. The same in energy consumption. On contrary, process reconfiguration cost and maintenance simplicity is low. So it is the figure about the journey of industrial revolution, the first industrial revolution until fourth industrial revolution. The change happened every 100 years from the first to second industrial revolution and from the second to the third industrial revolution. However, from 3 to 4 industrial revolution and from 4 to 5 industrial revolutions, it happened only one decade. Another source reported that the transition period from Industry 4.0 to 5.0 changed very shorter, only 6 years for the announcement of Society 5.0. The rapid movement will emerge the need of new expertises and skills. To survive, the society must be able to learn quickly and adapt to the changes. This is not easy situation, as it demands rapid learning and quick changing, whereas humans find it difficult to change, especially when they have reached their comfort zone. And that's why we need the lifelong learning. We come now to the third point, lifelong learning. Lifelong learning is a voluntary and self-motivated desire for knowledge. It gives a sense of fulfillment, improve one's mental health, and expand mindset. Effort can be made to solve this problem, including returning to human nature for lifelong learning. Industry 5.0 will focus on human working alongside advanced technology and AI-powered robots to enhance workplace processes. This is coupled with a more human-centric focus, increased resilience, and an improved focus on sustainability. Lifelong learning has no universal definition, but generally refers to the concept that there is always something new to be learned, either for personal, professional, or career fulfillment. Honorable distinguished ladies and gentlemen, there are many required skills for 2030. One of the skills required in this period is lifelong learning. There are some basic questions. What? Exploring new ideas, skills, and perspective. Why? Skills will expire faster, curious learners will stay relevant. And how? Spend 20 minutes each week learning a topic you know nothing about. And there are some aspects that related to the lifelong learning, technological literacy, leadership, self-motivation, emotional intelligence, agility, analytical thinking, creative thinking, AI and big data, talent management, and system thinking. Equipped with all abilities, the people will understand green industry and feel the need to implement it to ensure the sustainability on human race. Lifelong learning uses micro-learning as a learning approach. It breaks down complex content into small, manageable learning units and has emerged as a promising tool to support lifelong learning. It involves short focus segments on learning that can be accessed at any time and from anywhere, make it highly flexible and suitable for modern learners. Finally, there are some lifelong learners' best habits. The first habit is growth mindset. Second habit is time management. The third is self-motivation, and then reflecting on progress. And the fifth habit is SMART goals. Finally, we come to the last point, is conclusion. In conclusions, the interconnected concept of lifelong learning, green industry, and human life quality are crucial for achieving sustainable development. The green industry has a positive impact on most human development index parameters, contributing to a better quality of life. The dynamic and progressive nature of green industry requires resilience and adaptability, emphasizing the importance of lifelong learning. By embracing lifelong learning, individuals can acquire the skills and knowledge necessary to adapt to the rapid changes in the industrial era, ultimately contributing to the sustainability of human race. As the world transitions toward Industry 5.0, the focus of human-centric approach, resilience, and sustainability will rely heavily on ability of individuals to engage in lifelong learning and contribute to the development of a more sustainable future. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Kadarsa, for your inspiring presentations. Once again, we have to give applause to Professor Kadarsa. Okay, thank you very much. So let's next to the keynote speaker, the second keynote speakers. We will now proceed for our second keynote speaker. It is my pleasure to invite Associate Professor Flight Lieutenant Dr. Kontorn Kamni Prasad from Suranari, University of Technology, Thailand. His presentation title is Fourth Industrial Revolutions and Clean Energy. Associate Professor Dr. Kontorn Kamni Prasad earned his PhD in Mechanical Engineering from the University of Pittsburgh, United States of America. He currently chairs several engineering programs at Suranari, University of Technology, including Mechatronic Engineering, Precision Engineering, and Modern Automotive Engineering. His leadership experience includes serving as Vice Rector for Academic Affairs and Internalizations, Director of Center for International Affairs, and Dean of the Institute of Engineering. His numerous recognitions include the Thailand Education Leadership Award and CEO Thailand Award. His academic contributions span robotics, automation, electric vehicle systems, machine learning applications, and advanced precision engineering. We also wish to announce that our second keynote speaker will conduct in online. Professor Kontorn, Dr. Kontorn?
Yes.
Okay. Can you hear me?
Do you hear me?
Okay, thank you. Okay,
Okay.
Professor, you may now begin your 17-minute presentation. Thank you.
Okay. Did you see my screen?
Not yet, please.
I share my screen. You can see it. Okay.
Okay, thank you.
Okay. Thank you very much. Good morning, Director, distinguished guests, colleagues, and university friends. It's an honor to be here today to speak about topic the center of global transformation, the fourth industrial revolution for clean energy. The term Industrial 4.0 or the Industrial Revolution, I think it first introduced in 2011, and it's adopted and strategic initiative by German government in about 2013. So it's more than 10 years now for me know the word Industrial Revolution, the fourth industrial one. But do we change the way we teach our mechanical engineering students to achieve things? So today, I think I talk about around the world, the industrial are experiencing that we are in twin transition. What we call is twin transition is digital transformation and the energy transition. The urgent on energy transition is driven by climate change, the climate commitment to the global push toward to net zero. The key message I want to share to you today is clean energy cannot be scaled without digital technology, and Industrial 4.0 is becoming the most powerful enabler for decarbonization. Okay. So why Industrial 4.0 is matter for clean energy? Clean energy requires the digital intelligence to empower clean energy initiated by enhancing data analysis and decision making through technology like IoT and artificial intelligence Organization can optimize energy usage, reduce waste, and improve sustainability. Okay, so I want to show you three major reasons why Industrial 4.0 is essential for clean energy transformation. Okay, why it matters? First, visibility, the real-time data enhancement decision making. The intelligence we add after we see, we add the brain, the powerful brain to the system, and then flexibility. We integrate the renewable allow for dynamic energy management. Okay, let me go deeper into this. The real-time data for clean energy monitoring. We cannot manage things if we cannot see it. So to harnessing sensor from energy inside, so we can see what happened. The real-time monitoring, which 4.0 technology, machine level energy data is captured to intuitive dashboard. So we can see everything on the real time, providing insight optimization, energy management. Okay, so we turn the energy from the fixed cost into something that measurable, manageable, and optimizable. Next, the AI turn data into real saving. With accurate data, AI can advance and analytic. The AI can benefit us. Leverage AI enhance operating efficiency by detecting anomaly early, allow for productive decision make and resource management. For example, we can optimize motor and compressor performance. We reduce HVAC and thermal system energy consumption. We forecast load for renewable generation and automatically detect abnormal energy usage. And the last thing is I want to show you is flexibility in renewable energy integration. Integrating solar, BESS, and load shipping. This approach enhances energy efficiency and sustainability. For example, if we use the traditional energy resource with the renewable energy one, with the load shipping benefit, we can ship maximize solar energy used by adjust energy consumption to arrive with solar productive peak. And we can save a lot of energy without replacing equipment. So this flexibility can coordinate our energy use, shipping load, and synchronizing with on-site generation. The key enabling technology that is technology pillar for Industrial 4.0. Let me highlight 5 technology pillars driving the future of clean energy manufacturing. First, industrial Internet of Things and real-time monitoring. Sensor and edge device provide tracking of kilowatt per hour machine, energy use, power consumption, thermal, and load. So IoT connect device and smarter operation. Secondly, AI-driven energy optimization. On-model forecast load, detect anomaly, and recommend optimum system setting. This is especially powerful for high energy systems like chiller, boiler, compressed air, and production process with variable load. Next, the robotics and smart automation. Of course, robotics reduce scrap, improve predictability, and enhance process stability. all of which reduce energy embedded in defect and rework. Autonomous mobile robot also optimize logistics, reduce unnecessary movement and fuel consumption. Digital twin. Digital twin acts as a virtual model for plant. Engineering can simulate the airflow, the temperature distribution, energy flow, equipment behavior, and renewable interaction. This accelerates improvement while reducing risk. And last but not least, the blockchain for energy and carbon traceability. The global supply chain demand transparency. Blockchain enable traceable renewable energy certificate, verifiable emission data, and trustworthy carbon accounting. Let me show you a couple things about a practice example and success story. Okay, Schneider case study is real-world example showcase how Schneider building achieved significant efficiency improvement through Industrial 4.0 technology. This is one of the most widely recognized internationally cited example come from Schneider Electric's transformation of their facilities in France using EcoStruxure digital platform. This project integrates IIoT, advanced control, smart metering, and real-time analytics to optimize energy across the entire facility. Here the result. You have 41% improvement in overall energy performance from 2009 to 2021. Its saving cost about $282,000 each year for energy saving costs. And for carbon footprint, this about 5,800 metric tons of carbon dioxide emission reduced. It represents at about 88% reduction compared to the year that start 2009. All achieved to the digital monitoring, continuous optimizing, and coordinate control of mechanical and electrical system. This case proved that Industrial 4.0 is not just a concept. It's deliverable, measurable result in both cost saving and decarbonization. So this is not a pilot project. This is a large-scale operational factory delivering real financing and environmental impact. Okay. Second example is AI load control with solar. Factory with 2 to 5 megawatt rooftop solar often use AI to synchronize load with solar cell output. This typically reduce peak demand by 15 to 30%, lower electricity bill, and improve grid stability. Third, they are widely used in industrial right now is predictive maintenance. With IIoT sensor, it's enabled to detect an anomaly in plant, commonly reduce energy usage by 5 to 10% because equipment in poor health consume more power long before it fails. So if we can detect it at the beginning of defection, it can reduce the energy loss. So roadmap of energy transformation, I think it should be first, we have to measure everything. Install sensor and smart meter, create real-time dashboard. Establish energy baseline and KPI. The step 2, connect system. Integrate the software, can be SCADA, ERP, and cloud platform. Data must flow across the enterprise. Step 3, add intelligence, apply analytics, machine learning, and digital twin to uncover hidden inefficiencies and optimize daily operation. And the last step is integrate solar battery storage, heat recovery, EV fleet, and carbon tracking. Digital to ensure these assets work together intelligently. Come back to our classroom. I think the education for the next generation of mechanical engineering is very important, like I said before. The world changed for about almost 15 years. How are we doing right now? Investing in education for engineers will ensure competency in IoT, AI, and clean energy technology. Okay. For the role of engineering education, we want to build a cyber physical mechanical engineering. In our curriculum for mechanical engineering, we should include IoT and data-driven engineering. They have to, I think they should learn sensor fundamental, data acquisition, IIoT communication, interpreting machine level performance. After they gather all information, I think we have to teach them how to use AI and intelligent optimization. We have to show them the example of predictive maintenance, energy optimization, anomaly detection, system modeling. And of course, the last one is clean energy and decarbonization fundamental. HVAC and thermal system should be introduced with AI and IoT. Heat pump, heat recovery, okay, and carbon dioxide reduction in industrial process. I think we have to let them know, let them be aware before they graduate. So the new kind of mechanical engineering in the next generation of mechanical engineering must understand that machines are no longer isolated. They are intelligently machine, connect intelligently to intelligently energy system. Okay, so I think AI should be treated as a standard engineering tool like CAD today or CFD or control theory. Understand machine learning, basic outcome are completely. So I think I close my speak today is the new kind of mechanical engineering, the future clean energy, the industrial 4.0 is not only about automation. No, it's not about automation. It's the digital fundamental that enable clean energy to scale. Thank you very much for your attention. Thank you to be here.
Okay, thank you very much, Professor Contorn, for your insightful presentations. Please give warm applause again to Prof. Contorn. Okay, now we are going to the next sessions. Okay, the keynote speaker for our third keynote speaker is Professor Dr. Engineering Manabu Enoki from Tokyo University of Technology, Japan. This presentation title is Acoustic Emission Signature in Additive Manufacturing, Fundamentals and Applications. Professor Dr. Engineering Manabu Enoki is a prominent scholar in the field materials, reliability, and non-destructive evaluations. He earned his doctoral at the University of Tokyo, where he later served as associate professor at the Research Center for Advanced Science and Technology, and subsequently as professor at the Graduate School of Engineering. He currently holds the title Professor Emeritus at the University of Tokyo and served as professor at the Katayanagi Advanced Research Laboratories of Tokyo University of Technology. His research interests include acoustic emission of micro damage detections, reliability assessments of advanced materials, layered material systems, and data-driven materials informatics. His achievements have been recognized through major awards from Japan Institute of Metals and Materials and the Iron and Steel Institute of Japan. Professor Enoki, the floor is yours. You will have 17 minutes. どうぞお願いします。
Okay, good morning. So anyway, so thank you very much for inviting me this conference, and so I'm very happy to have give a talk. So my talk is related to the IoT and AI, but very specific topics. Yeah. Anyway, so let's start my talk. And so today, so I talk about acoustic emission. Maybe you know it's very similar to earthquake, and we applied this technique to the additive manufacturing. Okay. Okay. Here's the outline of my talk. So I firstly talk about just briefly the background of my research, and so I say about acoustic emission. This is the main topics of our research. And I showed some example of our technique and some additive manufacturing in nickel-based alloy, also titanium alloy. Okay, here. Okay, problem of additive manufacturing is a defect. So maybe you can produce very promising material using additive manufacturing, but sometimes we have a lot of defect in the materials. This defect decrease property of material, so we have to avoid this defect. And also we want to identify the defect during a process. This is our goal of research. And so here, so some example of defect. So you can see the void, also cracking. This is a very so sensitive to decrease the property. So we apply the acoustic emission technique to hear the sound from the material. So we want to identify the defect during the process, and we can control the process condition using acoustic emission. So maybe you know this is a very similar to the earthquake. So if some defect generated in the materials, we have some sound. And here's some the waveform of materials. And my question of research is, so we want to understand the damage revolution using AE. And also, we want to clarify the damage types, mechanism using AE. And also, we want to predict the property of materials using acoustic emission technique. And so we studied acoustic emission for, in my case, for more than 40 years. So we applied this technique of many materials. So many metallic materials and the composite materials, coating materials, and we applied this technique to the many process, thermal spray, laser shock peening, and the welding. And recently we applied this technique to additive manufacturing. And we developed a system of acoustic emission. This is so continuous wave recording system because the process generate many noise of sound. So we have to avoid this noise. So we decided to develop the continuous wave recording systems. So now, so this is commercially in Japan. So if you are interested in our system, please tell me. I can sell you. And anyway, so this is the PC-based systems. So we have all data were acoustic emission during the process. And after all the data, recording after the data, so we can apply the filtering technique to reduce the noise. We pick up the effective A signals. Here's the case of thermal spray in the ceramic coating on metallic materials. This is a very nasty process, but we can measure the acoustic emission and identify the cracking in ceramic layer using our systems. And here's additive manufacturing. So you can see, laser powder bed fusion system. So, the bedding the powder and laser irradiation. So maybe you can see the waveform. The left part. So you can see the sound. So this is the sound that comes from a defect in materials. So we successfully measure the defect in the materials using our systems. Okay, so I showed some example of our systems. So we applied this technique to nickel-based alloy. So here are some example of systems. So we apply the additive manufacturing with different conditions. So we want to have a good material, and we want to optimize the process condition. So we change the different process condition. And here, so this is a cross-section of materials. You can see the crack in the materials. So this is very dangerous for materials. So, and the lower part, you can see the waveform from crack. So we successfully detect the acoustic emission due to cracking. So this is some example. And and the advantage of acoustic emission is location. We can identify the location of a crack, so defect. So this is very important. Here's some example. So each point will correspond to the defect in the materials. So if a bad process condition, so you have many acoustic emission. So this is very important to increase the process condition of materials. And also, here's a cross-section of materials. So we observe the cross-section of materials, and also we compare with our location technique, location result of acoustic emission. So almost this located point is correspond to the observed crack area. So this is it means our acoustic emission technique is very useful to identify the crack in size of cracking, also location of cracks. And here's another example. So we change the process condition. Maybe so if you apply the laser bed fusion, so very process condition is very narrow. So in this case, we tried to different applied process condition, and we measure the acoustic emission, and we want to screening of process condition using acoustic emission. So here we have many acoustic emission. It means there is many defects in the materials. This is decrease the property of materials. We want to avoid this defect during the process. And also we can using some parameter of acoustic emission. This is related to the energy. So this energy almost corresponds to the size of defect. So if you apply the acoustic measure technique, so you hear the sound, so you can estimate the integrity of materials during processing. Okay, so another example also nickel-based alloy, and also we use AI technique to identify the defect in the materials. Here's some condition of process. And also so we hear the acoustic emission, and we check the volume of pore in this case. And so we compare with acoustic emissions amplitude with volume of pore. So clearly we have some correlation between pore volume and acoustic emission amplitude. It means so we can estimate the size of void during the process. And here's also the location technique. So we can find the location of a defect during a process using our technique. And here also so this is we compare with our acoustic emission result with X-ray CT. X-ray CT, so we can observe the inside of material using X-ray CT. So we compare the acoustic emission result with X-ray CT result. Okay, here's another example. We did a lot of experiment using manufacturing with AE. Okay, here's another asteroid alloy. So also we have many acoustic signal. It means also there is many defects during a process because nickel-based alloys some difficult to sound materials by processing. And here's a result, another result of cracking in this materials. So also, if there is a cracking, we have a lot of acoustic signals. Okay, and so we use AI technique to analyze the acoustic waveform. So here's result of short time frequency FFT. This is spectrum of acoustic emission waveform, and maybe you know the now so to identify the cat, so you can apply the AI technique. So also we apply this spectrum to identify the AE signals. And so maybe this is, you know the convolutional neural network. This is a very famous technique of AI. So we use this technique to identify our acoustic emission waveforms. Here's the result. So problem is we want to identify the pore and crack. And we have some data, acoustic emission from pore, and also we have acoustic emission from crack. So we use these data and apply the CNN. So we want to identify the pore or crack during the process. So this is a successful result. So we can estimate the pore or crack if you have acoustic signal. Here's another example. So our technique is very successful to the many materials. And also, question is why this CNN can identify the defect such as crack or void. So we can apply another technique of ground cam, so we can identify the origin of defect. So we clearly identify the pore and crack using this technique. And so final example is keyhole process in titanium alloy. Okay, maybe so you know, so we irradiate laser, and so this keyhole is some important process during additive manufacturing. So we want to this behavior using acoustic emission. And so keyhole number is so presented to express the so feature of a keyhole. And here's so a cross section or surface observation after the manufacturing. So and so you can see the depth of a keyhole is different if you apply the different condition. So also we have some plume during the process. So here's some observation result. But my idea is to identify this behavior just using acoustic emission. Here's so STFT, and here so, and if you the depths of keyholes are different, so acoustic emission behavior is also different. So we can identify the depths using acoustic emission. And so here's some example of keyhole frequency and the depth of the keyhole. So you can see the clearly some correlation between depth and acoustic emission frequency. It means if you hear the sound from defect in additive manufacturing, so you can estimate the keyhole behavior using this result. Okay, so we applied this method in another material, stainless alloys or something. So anyway, so we have a similar result. So we have some correlation between keyhole depths and acoustic emission frequency. And also in the titanium alloy, also cracking occurs. So we can successfully detect the cracking. So we have two types of sensor with a microphone and also piezoelectric sensor. So if you want to analyze data, so maybe so you select a proper sensor to identify the defect in materials. Okay, this is a case of a pore. If you change the condition, so pore distribution is different.
Professor,
but,
1 minute remaining.
Okay, sorry. We have different properties. Okay. This is the final slide. So if keyhole frequency is very correspond to the plume instability, maybe the instability is a big problem in additive manufacturing. So here, so you can see the change of frequency. This is related to the instability of a plume. So if you use acoustic emission, so you can identify the plume behavior. Okay, and so this so and depth of keyhole is a cross section and correspond to the acoustic emission data. So we completely so match the depth of keyhole is correspond to the acoustic emission behavior. Okay, so this is the final slide. So and AI and IoT acoustic emission is a very promising tool in additive manufacturing. Okay, thank you very much.
Okay. Thank you very much, Professor Inoki, for your interesting and technically rich presentations. Please, you may sit in front after question and answer finish. Okay. Okay, now we are going to the third keynote speaker. We are honored to welcome Professor Dr. Insinyur Rianti Dewi Sulamet Aryo Bimo, STM IPU from Universitas Trisakti, Indonesia, Jakarta. Presentation title is Applying Thin Wall Casting Technology in Ductile Iron Components. Professor Rianti Dewi Sulamet Aryo Bimo is a leading authority in ductile iron metallurgy, thin wall casting, and heat treatment process. She is affiliated with several professional engineering organizations, including the Indonesian Engineering Associations, the Indonesian Foundryman Society, and ASM International. Professor Rianti has authored more than 40 scientific publications and holds multiple patents relating to innovations in ductile iron casting system, thin wall component manufacturing, and sustainable iron reduction technologies. She has received numerous awards, such as L'Oreal Women in Science Finalist Recognitions, multiple Best Paper Distinguished, and Intellectual Property Awards. Okay, Professor, you may have 17 minutes. The floor is yours. Thank you.
Thank you, Dr. Anissa. Please allow. Not yet. Okay. Okay, thank you. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Since I was given by the moderator the last one, and I know that all of you is already hungry or maybe tired because the previous keynote is very serious and very interesting, the sharing. Thank you. Now I just give a little bit sharing regarding our research here is about the applying thin wall casting technology in ductile iron component. In fact, this is the progress report from the Ista-Am into 2024. So for the one who attend Ista-Am 2024, this is the report. Okay. Now, let's see about these materials. People are changing. Before, everyone always want to use this kind of bricks. But now everyone is moving to this type, and the latest is this type. Or this one. People tend to use this one, but now they are going to the hollow one. This design, the old design, goes the new design. And also this one is one of the component, and this one. Why are people doing this? Because they want to lighter the component. Why lighter? Because when it's lighter, the component is lighter, it will consume less energy. When less energy, fuel cost will be reduced. Lighter will also means lower emissions. Lighter is also mean that less time productions. This is all the advantage when you can lighter your component. Right? And the last one, that's why I give it red color, because marketing will be up Yeah, because you now can, if people want special design, with more lighter, you can adapt with that, and people will buy your thing. Now, how can we make component become lighter? There is two ways. One, change the material. Use lighter material. And the second one is redesign, like the one that happened to the bricks. But when we are talking about material replacement, yeah, there's a lot of modern materials, especially in the composite. But like this one, this is the, you know, the marbles, the real marbles. But now we have a plastic marbles, the PVC. This price is, the price of this is, I think, about 10 to 15 times this one. This is very cheap, and everyone can put it in their house, just like that. So people will thought that the house is fully marble, but no, that's not a fully marble. That is just the PVC marbles. Yeah, this is one of the examples for the material replacement. Or like this one, before you are using the steel, but now you can move to the carbon fiber. Yeah, but when we are replacing a new something with new materials, there is some parameters you have to think. Usually, when we talk about new materials, it's a high-tech material, right? Composite is very hard to make. You need a very high materials, and then new material tends to be expensive. Because of the high-tech, then it becomes expensive. Or when you are going to make a new materials, you have to invest more because you have to change all your factories. Or you have to find a new suppliers because your old suppliers don't supply that things. For instance, like the marbles and the PVC. And then we don't know about the strength. Is it the same thing with the one that we use? Maybe in one hand, yes, but I don't know in the other hands. And finally, if everyone using a new material, how about the old materials? How about the company or the small-scale industry who provide the old materials, the existing materials, I'm sorry, not the old one. Okay. When we are talking about design changing, maybe you know this is Mercedes-Benz, from the old one until the newest one. Yeah, it's easier for them to do the design changes more than to change the materials. Now, as we enter the research we are expertise, or we are playing with the ductile iron, and we know that ductile iron is been used till 1943 until now, and officially in 1944, because the 1943 is the first time ductile iron was invented. And then there is the austemper ductile iron, is the brother of the ductile iron, but got higher strength, which is invented to replace the forged steel. And then in 2000, we got the thin wall ductile iron and thin wall austemper ductile iron. Now, as I mentioned before, that ADDI is invented to cope up with forged steel that time. Why? Because when you are using ADDI, you got a similar strength, you got similar properties with the steel, but the process is more simple and the price is more cheaper. Okay, what we do in our research is we combine the material replacement with a design adjustment. The material replacement here, we still take the old materials, that is the ductile iron, but we redesign the structures. We renew the structures so ductile iron, which is not a light materials, can act like light materials. So we are playing in the design. Now why we still stay in that old materials? Because we found out that, see, the elongation, the characteristic and everything, they can compete with other materials, still can compete. And this is the real things that make it very interesting. The production cost. Okay, and this is the damping capacity. Okay, this is our road maps, and it's begin in 1993 until now. And this is the project that we have made. Sorry. Okay, the first time our team is trying to make a plot, a very thin casting plate with the thickness, the latest one is only 1 millimeters. Why we make it this plate? Because we want to know the characteristics. We need all the data, the characteristics and everything, and then based on what we got in the plate, then we try to apply all the parameters in making component. One is the connecting rod, and then the other is the housing for electric housing. Now, as I mentioned before, that this is the continue from the Ista-Am 2024. In that Ista-Am 2024, our next work is making a hollow connecting rod. And then from this side is the 3D printing pattern and then casting process. And now this is what we report, that this is the design modification we made to lighter the connecting rod. Yeah, then this is the design. The old one, I mean the real connecting rod have 4 millimeters in the I-beam. Then slowly we reduce it to 3, 2, and 1 millimeters. And the last one is the hollow one. This one is really empty. Now, this is the first design we used to produce the plate. And from what we got here, then we invented to make the connecting rod. And oops. Okay, we do all the analysis, the strength analysis and everything to make sure that the place we do the thinning is not the critical one. We use this, the analysis, and then we also do the casting simulations. Oops. Okay. Casting simulations. And then this is the last result we have. And this is the 2 millimeters, and this is the hollow one. Yeah, we have made the hollow one, and the compression is almost the same like we have in the non-hollow one. And you know that when we are doing the tining, when we make it more lighter, we have to guarantee that the characteristic is still the same. And this shows that although we do it like this, we still can got the characteristic. And this is the microstructures, and when you see the microstructure, it's the same, yeah, so nothing changed so dramatically. And when we enter the other component, which is the electric motor housing, we also do first the analysis of the strength analysis, and then this is all the simulation, casting simulation. And finally, we have succeeded making the pattern by using the 3D printing. So this pattern is made by 3D printing. Why? Because the pattern is so complicated with all the here, oh, sorry. And wait. And using this pattern, we do the casting, and this is the result. But the casting is still need to be adjusted because you can see there's still so many shrinkage and everything in here. So, but finally we can make the housing, the motor housing. And this is the other finding that we found during making that lighter connecting rod. Yeah, we need to make a special device to do the compression test, because the compression test is not made in a specimen, specimen that destined by GIS, but we really do it on the component. So the cast component will be compressed in this machine. And we also built this machine. This is for investigating the fatigue. And that is our next project. Oops, sorry. Is that all? Okay, thank you very much.
Okay, thank you very much, Professor Dr. Rianti, for your interesting, insightful presentations. So now we are going to the next sessions for question and answer. Okay, participants are invited to raise their hands. Okay, raise their hands, or in online you may write in the chat box for the questions, please. I think we have only 20 minutes for question and answer. Okay, please. Is there any raised hands? Okay, please. It's okay.
Thanks, Professor Enoki and Indriati, for the talk. Hello, my name is Arif Budiman. I'm from Oregon Tech. Thank you again, Dean Rianti and Prof. Enoki. Defects are really important for additive manufacturing, especially for advanced structural materials. And Dean Rianti, I think I don't have question. I just have a bit comment. I think really the short answer to your question earlier about like why do we change from, let's say, connecting rod with 3D pattern of thin wall structure. Well, the short answer is because we can. Now, with additive manufacturing, because we can. Prof. Enoki, really enjoy your talk. You mentioned about the correlation between your AE intensity with volume of the pore, of the void. And then later you use AI to detect, to identify whether it's a void or it's a crack. Can you identify or detect the direction of the crack, like if it is horizontal or if it is vertical or like any direction of a crack? That's my question. Thank you.
Okay, thank you very much. Please, Professor Enoki.
Okay, thank you very much for your question. So also we are interested in clarifies orientation of crack. Yes, sometimes yes, but sometimes very difficult because we have many sensors to detect acoustic emission. Maybe it's possible, but maybe you consider the processing. So very 3D printing is very how to say that, very limited space sometimes, and also you produce many types or geometry of so product. So in this case, so if cracking occurs horizontal and vertical, but maybe sound is different. It depends on the geometry. So, and it's very difficult to completely predict the orientation. But if you so limited product, limited process condition, maybe it's be possible. Okay.
Okay, thank you very much, Professor Enoki. So please raise your hand. Okay, please. Please introduce yourself.
Assalamualaikum. Very good morning. I'm Azian Muhammad from University Technology Petronas. I'm quite interested with Prof. Enoki. Is it okay? About the acoustic emission, because I'm also using acoustic emission since my master program until now. I got two questions here. The first one is from your research that you have been performed before this. Can you detect the sizing of the maybe crack? Or if you are doing the void, can you detect the sizing of your failure damage? Let's say it's a crack, so can you detect the crack size or the crack depth? Even it is a void, can you detect the length of your void, the length of your crack? That is one. And one more thing is, do you experience any application or research on the elevated temperature equipment? To use the acoustic emission on a very high temperature equipment. Let's say I have boiler at 800 degrees C. I want to monitor the crack behavior using acoustic emission. Thank you.
Okay, thank you. Okay. So also we are interested in the sizing of pore and the cracks. And so I show my presentation. So we compare the pore and acoustic emission amplitude. So we have a clear correlation between pore size and acoustic emission amplitude. However, in the case of cracking, also acoustic emission amplitude is very related to the cracking size, but it's difficult to say clear correlation between sizing and amplitude or something. Yeah, maybe so. This may be next problem. So maybe we have to improve the analytical technique to identify the relationship between size of crack and acoustic behavior. Okay, temperature.
Yes.
Yes. As usually we use PZT. It's a piezoelectric sensor. So in this case, this sensor has a Curie point, maybe 300 degrees C or something. You cannot apply the PZT over temperature. But I show the microphone to hear the sound. It's maybe not so high frequency, maybe up to 50 kilohertz. So still we can hear the sound from a microphone. So in our presentation, so we can correlation between power and so this acoustic emission behavior. So maybe you have some sensor you can apply the high temperature.
Okay, thank you very much, Professor Enoki. I hope that he answered your questions all. Thank you. Yes, okay. It's okay.
But Professor Enoki, I thought you mentioned there is a good correlation. You show it like for void
yes, we detect the acoustic emission due to the void or power because this is so oscillation of void. So we can change the frequency. So we can estimate the size or depth of defect.
Okay, thank you very much, Professor Enoki. Okay, please, is there any questions? Please raise your hand, or you may write down in the chat box. Okay, those are, this. This. Introduce your name, sir. Don't forget to introduce your name. Thank you.
Good morning. My name is Endang. I'm from Trisakti University. My question is for Professor Rianti. You show in the presentation that the advances in the casting technology is still growing quite strong. But now with the coming of the additive manufacturing techniques, how do you see the Indonesia direction in manufacturing, consisting these two competing technology or complementing technology? Thanks so much. Thank you.
Please. Thank you very much. Okay, please.
Thank you. You give me a very, very hard question to answer. Yes. Indonesia got several levels of industry, right? The highest, the middle, and the low, and the small scale. Additive manufacturing, maybe you can use for the high level and the medium level. You can go there with the additive, and with a model that is more and more non-mass. So special order, something like that, you can use that for using the additive manufacturing. But when you are talking about mass production, like casting and everything, I think for Indonesia, this is for Indonesia, I think it's better you still use the old way, the old manufacturing way, because we still can compete in price and everything. Maybe that is from my view, okay? But maybe there's other view. But yeah, because when you are using additive manufacturing for mass productions, I don't think they can keep up with the price. I hope that can answer the questions. Thank you.
Okay, thank you, Prof. Rianti and Pandang. Thank you very much. So, is there any questions? Yes. No chat from the Zoom? Okay. Okay, nothing? Nggak ada kayaknya. I think it's okay, we don't have any more questions, so I think it's time for me to summarize these presentations. Okay, allow me to present a consolidated summary of today's keynote speakers. First, Prof. Kadarsah underscored the strategic importance of lifelong learning in strengthening the resilience of the great industry and improving societal well-being. And the second professor, Associate Professor Contorn, highlighted the transformative role of the fourth industrial revolutions in accelerating clean energy innovations and enabling advanced digital technologies. And the third, Prof. Enoki provided a comprehensive expositions on the use of acoustic emissions techniques to enhance the reliability and quality assurance of additive manufacturing processes. The fourth, Professor Rianti presented significant advancement in the thin wall ductile iron technology, contributing to lightweight, high performance industrial components and sustainable manufacturing. Collectively, these presentations empathize the critical role of sustainability, digital transformations, advanced material science, and engineering innovations in shaping the future of global industries. Okay, ladies and gentlemen, this concludes the keynote speaker session of our international sessions. We extend our deepest appreciation to all keynote speakers for their invaluable contributions, to all the participants for their engagement. Thank you, and we wish you to productive continuation at the conference program. We now return to the moderator. Thank you very much.
Thank you, Ibu Dr. Anissa, and thank you, Ibu Profesor Rianti. Thank you, Professor Manabu Enoki, and also thank you to Professor Kadarasa Suryadi and Dr. Konton Champin Prasad as the keynote speakers for today's event. So after this, we have the token of appreciation. Therefore, to all keynote speaker, Prof. Rianti, Professor Enoki, would you please to stand aside in the front of here for the token of appreciation? Okay, and to represent Bapak Profesor Kadarsa Suryadi that already delivered in online, we would like to invite the Vice Dean 1 of FTI, Ibu Dr. Insinyur Nora Asmi MT, to please welcome for representing the token of appreciation. And for representing Dr. Konton Champin Prasad, we'd like to invite Dr. Witaya Daudon from RMUTI Thailand to represent the delivering of token of appreciation. So please welcome. All right, so for delivering the token of appreciation, firstly, we'd like to invite Dr. Muhammad Rizwan from UNIMAP for deliver the token for Icadme keynote speakers. And also we'd like to invite Professor Arif Budiman from Oregon Institute of Technology to deliver token of Ista-Am keynote speaker. So please welcome. So ladies and gentlemen, we will begin for the token of appreciation to all keynote speakers of Icadme 2025. So please, Dr. Ridwan, to deliver the token of appreciation. Firstly, to Professor Kadarsa Suryadi, that on behalf of the Vice Dean 1 of FTI, Ibu Dr. Nora Asmi. Thank you. And for the next one, this is token of appreciation to, and this is the certificate. Thank you very much. And for the next keynote speaker to Dr. Konton Champin Prasad, that on behalf of him, this is Dr. Witaya Daudon from RMUTI Thailand. Thank you. And for the next token will be given for Ibu Profesor Rianti Dewi Slamet Aryo Bimo. Sure. And the next one, we'd like to invite Bapak Profesor Arif Budiman to deliver for the keynote speaker of Ista-Am 2025, Professor Manabu Enoki. So please, this is a token of appreciation and the certificate of appreciation. Okay, and one more. This is the certificate giving. Okay, thank you very much, professors. All right, and next, this is for Icadme 2025. So we'd like to invite again Dr. Ridwan to give the token of appreciation to Icadme keynote speaker, Ibu Profesor Rianti Dewi Slamet Aryo Bimo. Thank you. And last but not least, for moderator, we'd like to invite the Vice Dean 3 of FTI, Bapak Insinyur Amawi Tonohadi MT, to give the token of appreciation to our moderator, Ibu Dr. Anissa Bikuning. Thank you, ladies and gentlemen. So you may have the photo session together. And please, to our protocolar team to arrange the position. Okay, and also we'd like to invite Bapak Rektor Universitas Trisakti. Yeah, and also Dr. Zaki as the chairman of Ista-Am. And Dr. Fauzia, please welcome, chairman of Icadme 2025.
And there is Professor Konton Prasad.
Yeah, and also we'd like to invite Dr. Konton Champin Prasad to join online for the photo session. Okay, can we just hold for a second? Our team will arrange the frame. Okay, and one more time online with our keynote speaker, Bapak Rektor and Dr. Champin Prasad as well. Okay, all done, all said. Thank you very much, especially for our keynote speaker, Bapak Profesor Kadar Sasuryadi, Dr. Konton Champin Prasad, Profesor Manabu Enoki, and Profesor Rianti Dewi Selamat Aryo Bimo. So, and ladies and gentlemen, all distinguished guests, to successing this international conference, Icadme 2025 and Ista-Am 2025. Thank you very much, ladies and gentlemen. So you may heading back to your seat. All right, so as the information for today's event, after this, we still have the parallel session to all presenters for Icadme 2025 and also Ista-Am 2025. And now, before heading for parallel session, all participants is allowed to have lunch, and lunch is already served at the room beside this auditorium. And for the information for Muslim fellow, if you want to conduct the prayer room or musola is at 4th floor, or if you want to go to mosque or masjid, there also has masjid outside this building. And also we'd like to let you know about the gala dinner. At the evening, all participants are invited to join the gala dinner today at 7 p.m. in this auditorium as well. And last but not least, we'd like to say thank you to our sponsors for supporting this event. Thank you to the Boeing Company, Talent Corp Corporation Malaysia Berhad, Asia Berseri Vision, Math Proofread, Sanfotech, and PT Geodipa Energy Persero. So that's all for today, and we'll see you later on parallel session. So have a great presentation and sharing knowledge. Thank you.
you.